Okay, this video is going to illustrate how we can calculate mortgage payments that only includes interest and principal payments using Excel. So as you can see, this is the Excel, and let's suppose that we have a house to buy, price of house, and let's say that amount is gonna be $1.5 million, just like this. And then let's say we want to make a down payment of we are gonna make a down payment of $300,000. Okay, so the amount of the loan is the difference between these two, of course. So it's $1.2 million. And suppose the loan period is 30 years. And suppose that the quoted rate is 9%. Okay, so we should have enough information. And the issue for mortgage is that it's gonna be monthly payment, and that means we're gonna pay every month, so 12 months a year. So for 30 years, it's gonna be 316 months, right? So we will need to do some calculations before we can construct the amortization schedule. So first is that we need to calculate the monthly rate, which is a periodic rate. Monthly rate, which is a periodic rate. So basically, for every period we're making a payment, we are going to be charged this amount of interest. So because the quoted rate is 9% and it's compounded monthly, so every month you make a payment, so it's going to be 9% divided by 12. So it's 0.75. It's going to be 7.5%. Here we go. Okay, 7.5%. So then we want to calculate the payment. Okay. Oh, the payment. Okay, so the payment for a mortgage or any amortizing loan is going to be the same for all the periods. So basically for this 360 periods, we're going to make the same amount of payment. And by the end of the 360th period, we're going to make our last payment, and our last payment is going to be just enough to pay the interest for the last period and the remaining principal for the last period. Okay, so how do we calculate the payment? The payment is basically the amount of a equally monthly payment that's going to have the same present value at a monthly rate of 0.75% as the loan amount, that is 1.2 million. So basically, as long as the present value of all the payment equals to 1.2 million, when we use a monthly return of 0.75%, we find the payment that's the right amount. So to get that, we're essentially just calculating the payment of an annuity cash flow. So using Excel function, we're going to use the PMT function, which is short for payment. And the first argument is the rate. The second argument is the number of periods. So the number of periods should be 30 multiplied by 12, which is, again, 360 months. And the present value is going to be 1.2 million, which is this. But I'm going to have to put a negative sign in front of it. So if I don't, then I'm going to end up with a negative number, which is a little confusing. So instead, I'm going to put a negative sign in front of the loan balance. Well, unfortunately, you cannot put negative sign on the others. For example, you cannot put a negative sign in front of the rate. You cannot put a negative sign in front of the number of periods, because mathematically it won't make sense. So this is it. So there are two more arguments, including the future value. The future value is very similar to the financial calculator future value. If you have watched any videos or you have learned about financial calculator, the FV on the financial calculator is a lump sum cash flow that's going to be received or paid at the end of the period. In this case, it's the end of the 360th month, or at the end of the 30th year. But we won't have any, so we won't do any payment other than the equally monthly payment we're doing. So we're not gonna have that. And the last one is type. Type is basically the beginning of period or end of period switch. So if you put 0, or by default, it's gonna be the end of period convention. If you put 1 or just 1, then it's gonna be the beginning of period convention. So we don't need to mess up with these two. We just accept the default. It will be fine. So we got 9,655 and 47. Okay, so we got the payment, and once we get the payment, let me make it look a little better. So once we get payment, we are ready to construct the amortization schedule. Okay, so amortization schedule, this thing, or the schedule we're trying to work with, is gonna have a lot of applications, but for now we're only applying it to mortgage, which is a very common amortizing loan. So there are some other amortizing loans that you can find, or you can self-construct, but they're gonna all fall in the same way to calculate. Okay. So let's begin with what we want to put in the amortization schedule. The first thing we want to have is the beginning balance. I'll just use beginning BGBAL. Okay, beginning balance. The second thing we want to do is we want to say it's the payment. And another fun fact about amortizing loan is that the payment is going to be partly going to the principal and partly going to the interest. So we want to split that. So the first is the interest payment and principal payment. Okay, we're going to have 2 columns for the payment, and then in the end we're going to have ending balance. Okay, so these are all the items. And of course, we need a column to keep track of the number of periods, that is the month. Okay. All right. All right. Let's just do this. Okay. So we have the same. Okay. So I have this, and then of course I want to put in the month. So month number 1 is going to be 1. Month number 2 is going to be the previous one plus 1. So if I copy and paste a couple more, I'm going to have 3 and 4. So I'm going to keep going until I have number 360. So there are smarter ways to fill this, but this is just a faster way. Okay, less smart but faster way. So the beginning balance of month 1 is obviously the amount of your loan, right? So at the beginning of the first month of your payment, you're gonna still owe $1.2 million, and the payment is gonna be this amount, 9655.47. Okay, so remember the dollar sign. You really need it. And the interest payment is a result of the beginning balance of the month, right? At the beginning, I owe $1.2 million. And I need to pay a periodic interest rate, which is 0.75%. So C7. Okay. So the interest payment for the first period is going to be $9,000. And part of our payment goes to the interest, and the rest goes to the principal. So we have the principal reduced by $655.47. And the ending balance is gonna be the beginning balance minus the principal payment, and we got this much, so not too much difference. And then in the second month, the beginning balance of the second month is gonna be the ending balance of the first, right? So at the end of month one, I have paid $9,655, and 9,000 of which is just the interest, but 655 and 50 cents is going to the principal. So our principal is reduced by that amount of money. So all those happen at the end of the first month. So the end of the first month is essentially the beginning of the second month. So the beginning balance of the second month is just going to be the ending balance of the first. Okay. And the payment will be the same. I'm just going to copy this and paste it down here. So we're going to have the same payment. And the interest payment is going to be based on the same calculation. That is the beginning balance multiplied with 0.75%. So copy and paste. I got the beginning balance of the second month multiplied with the interest payment of the, interest rate of the periodic or of the period. So it's 0.75%. And then for the first, for the principal, it's still the payment minus the interest payment. So copy and paste. As you can see, we have more money going towards the payment, right? Roughly $5 more. And then the ending balance is also the same calculation. That is, we use beginning balance minus the ending balance. Okay. So as we have everything filled up for the second month, all we need to do is just to double click, select all these and double click at the corner, and we're gonna automatically fill up this table. So if I go down, as you can see, the ending balance is $0, right? So I mean, it's just as precise as pennies, but we have 0, okay, less than 1 penny at least. So if you look at the principal payment, which is this column, right? That's the, the interest payment, that is this column. And if you look at the principal payment, that's this column. You're going to see that the principal payment is increasing from about 655 to 9,583. So our total monthly payment is just 9,655. So in the end, the almost all the payment amount is counting towards the principal. And the reason is that you pay just so little interest because you have less and less beginning balance you use to calculate your interest. Okay, so this is how we construct the amortization schedule. So if you have any questions, let me know.